Hey, guess what? It's another e-learning day. I decided I would do this video in case you are having problems with the Zoom or you forgot to log in or whatever the case is for today. We are now on Tuesday of e-learning. I want you to do the e-learning check-in, which you can see right here. After you do that, make a copy of this note guide right there. And once you have the copy of the note guide, it is just a few slides. And then make yourself a copy. And then if you want, once you're back at school, you're welcome to print that out during your freshman focus or SRT, as the case may be. And you've already got it filled in. I did make sure that you could write on this a little bit easier than if we were at school and I gave you a paper copy of it. So I did think about that for you. And then I will be going through the presentation, which you will find click on Unit 4, Why Skin Color. And then that takes you to here. And then we have been pretty much following this map. So we've done the driving questions, and that took us 2 days with e-learning. So we are now ready for the Pedigree Notes, and that's where we are today. So we are jumping over here, and the note guide is what you just made a copy of. And I am going to walk you through the presentation. So here we go. Let's get started. Okay, so some important vocab. Maybe you remember this, maybe you don't. Let's make sure we have it in our notes. Alleles, different forms of a gene. So in this case, we're talking about the gene that causes albinism, which will ends up being recessive. Then we have genotype. That is the genetic makeup of the organism. Do you have a big B, little b? Do you have big A, little a? Phenotype is what we physically see. So are you an albino, or are you a regular producing melanin person? So melanin is the pigment that allows you to have darker skin. How many alleles do organisms have for every gene? 2. Why? Do you remember this? You get 1 organism from each parent. 1 from your mom, 1 from your dad. Okay, so one of their goals in doing a pedigree is to be able to identify the genotypes of the individuals in a pedigree. And we will walk through how we do this given information. So several of you remembered this when we did the assignment yesterday, that they're similar to family trees. They show your different relationships. Some of you have remembered the word traits. Many of you remembered things that one of them was a female, one of them was a male. Some of you remembered even that the shaded one tends to be the trait that we were following. So these are the things that we want to be able to say that we know. Let me double check and make sure that you have these things. Okay, I'm looking at my note guide over here. Okay, they track the traits through the families. So if you did not know this, this is a point where you definitely want to write it down, that the circles are females, that the squares are males. Shaded means that's a trait that we're following. And in this case, in the case of what we were doing the last couple days, it was albinism. Always when we're looking at a pedigree, we want to figure out how many are this and how many are that. So let's look at this one. So now that we know that the squares are male, how many individuals in this pedigree are male? Go ahead and count those out. You should have counted 7. How many individuals, let me move this up here, are female? You should have counted 6. Last question on this slide. Which individuals have the genetic disorder? List the numbers. You should have said 1, 10, and 12. These are typical questions that you might see on an exam. So make sure you're getting these. You're not just waiting for me to give you the answers. So let me pop this down here. So we're going to look at PKU as our first example. And that will be on our next slide, your next notes. Everyone has this test as a baby. They do a little prick test on the heel of the baby's foot. And they want to make sure that they don't send a sick baby home because, oops, let's go back a little bit. Okay, so phenylketonuria is also PKU for short. It's a rare inherited disorder, but it happens often enough that they're testing every single baby because if they don't catch it, it leads to brain damage. It builds up to a toxic level and will destroy the brain. And then now you have a baby that could have been treated, and instead the baby ends up brain damage because we just didn't know. And so this is also why you will see signs on different things that will say, hey, this does contain this. And the treatment for it is simply a supplement for the baby, for the person. So it's not like it's bad for the baby or the person that has it unless you don't know you have it. Okay, so similar to family trees, we already said this. Okay, so here we have 2 healthy individuals. You don't know that you have it. Maybe no one in your family has shown it because it's a recessive trait. It can hide for many generations. So I don't care, pick whoever you are. So this female marries this male, and they have 4 babies. The first baby, I think I'm in the wrong place again. Okay. Yeah, the first baby gets 2 dominant traits. They're going to be healthy. The second one gets 1 dominant trait and 1 recessive trait. That baby's normal. Next baby also gets a dominant and a recessive. And then the last baby, and remember, this is totally random. That last baby gets both recessive traits, 1 from mom, 1 from dad. That baby is going to have the PKU disease. Okay, so now we have the story. Here's our story. And you have these guys on your note guide right now. So Manna and Rosa are married and they're both healthy. They have 3 children. Their oldest child, Jacob, has the disease, PKU. Their middle child and the youngest, Erica and Matthew, are both healthy. Go ahead and get those genotypes in. So we know Jacob has it. He's little h, right? That's what we have on our screen. Okay. Well, if he got the disease, then we know which of those 2 is true. And what can we say about these other 2, right? Well, we know both Manna and Rosie must have 1 little h because they had to give each little h to Jacob. We also know that they have 2 healthy children. But first of all, we can rule out that neither one of them are big H, big H. Okay. Now we look at Erica and we look at Matthew. If we do a Punnett square, big H, little h times big H, little h, Okay, that's what we get. There is a 1 in 4 chance that they have big H, and there's a 50% chance that they have the big H, little h. And they cannot be little h, because they don't have the disease. Without further information, we either put a question mark like that, or we can put a underscore, meaning that we don't know yet. Either one is correct, depending on how you want to do the pedigree. Now we have more information. With more information, Erica meets someone who is healthy. His name's Mo, and they become married. Erica and Mo have 2 daughters. Their youngest daughter has PKU, but the other daughter, Amy, does not. Go ahead, get Erica, Mo, Amy, and Jamie on there. Well, Erica's on there. So Erica meets Mo. They have the 2 daughters. The daughters, so they're circles. Jamie has it. Amy does not. So we know automatically Jamie's little h, little h. Well, same question that we've seen before. We know automatically that Erica and Mo both have to carry the small h. We can cross out that big H, big H. We now can replace that question mark under Erica with a little h. And we know Mo is also big H, little h. So these guys, the big H, little h's, sometimes we call them carriers because we don't know by looking at them that they are carrying something. And with Amy, we're going to have to give her the question mark again, because if we do the Punnett square, we see that she does have a chance of not being a carrier. So without more information, Matthew, we cannot declare anything about. If you get more information, we can then fill in stuff about Matthew. Also, we do not know anything about Amy other than that she is carrying one of the normal healthy genes for that particular disease. Okay, so now we're going to do one for sickle cell. Yes, you have one for sickle cell as well. Okay. So this is the sickle cell recessive traits. I've got the entire group already there for you. And there are 3 that are unknown. I'm going to let you work all the way through that. So we know in this case, we're going to stick to big H for healthy again and little h for sickle cell. So this is also recessive. You have to have 2 little h's to be sick with sickle cell. And I have yours so that you can go ahead and write in the genotypes on that. Your last thing to do today will be to go and tell me who your 3 unknown people are. Okay, guys. Enjoy the rest of your day.